Hello everyone. In this video, I'm going to go through segmentation using 3D Slicer. We're going to primarily focus on segmenting medical imaging data. And in addition to that, we're going to look into a MATLAB GUI in which we optimize transformation from one reference robot's reference system to another robot's reference system using pair point matching. Now I'm going to begin with the 3D slicer. I'm going to select a sample data. I've already downloaded the CT chest, and in order to start segmenting or selecting parts of your 3D data, you'll go to editor, select OK, and from here I'm going to choose the paint effect, and I'm going to use it with a threshold, and I'm going to try to get the outer cavity of the lungs in this CT image. So I'm going to start from the bottom, approximately right here, and I'm going to increase the size of this brush to larger than this, actually, to approximately 100 millimeters. And for the thresholding, we're going to have to experiment and see what gets highlighted and what doesn't. So selecting that, we see that it highlighted most of the area that we want, but there are some areas that did not get highlighted that we wanted highlighted. So we'll increase the threshold range and undo and attempt one more time. In this case, we got most of what we want. If we were more careful, we can, select a smaller brush and not include the inner region. I'll move on to the next slice and select another. Now this is just an example, so we're not going to go through all the different slices, just enough to show how this works. So after having selected a couple of segments in each slide, I'm going to create a 3D model of this. To do this, you use the Make Model effect and you select Apply. Here at the bottom you can see part of our 3D model. Now I'm going to move on to the MATLAB part and show you what I have done for assignment 3. So I have used the same DH parameters I've been using for assignment 1 and 2. Here you can create, given distance x, distance y, from the base of robot 1 and angle, create, and you can control the robots 1 end effector using this panel, and you can control robots 2 end effector using the EE2 controller panel. Under here it shows the end effector location for both robots. This XYZ is according to the reference of robot 1. Now you can move these controllers, move them such that they're exactly at the same orientation and position for the end effector, and you may add the point. Now I'm going to go do a quick example of that, where I'm going to, for example, let's say move L1 downwards one point. Now what I'm going to do is I'm going to try to match these two. So I'm increasing in X to match the X coordinate of the end effector of E2. Now I need to decrease Z. Now they're equal, but their orientation is not, so I'm going to attempt to equalize their orientation. Let us see. Here we approximately have their orientation matched. Now we have to go back and make sure the end effectors are exactly matching. Here we see that the x needs to be increased, and thus we have a perfect match. Now I'm only storing, since we have the same xyz, since the end effectors match, we're only storing one pair, and we can this way add a point. And not going through many examples, I can load a default set of xyz. These, before the optimization function is run, are stored in data.txt. Also, the dh params are stored in data in dh params.txt before the fmin search is run, so they can be used in the fmin search. Now I'm going to load the default, and not to consume too much time, this is the actual transformation matrix, and this is the calculated or the process transformation matrix based on the experimental values. Here I've included 5. Here you can include how many object function calls you would like. I think it varies between 10 to 100. I'm going to choose a small amount since it's very slow, and I'm going to run the optimization. As you can see here, here's the error in each function call. You can see it's going to be decreasing, and here you see the initial processed transformation matrix. It went through 5 iterations, and the error is 4.3. Thank you, everyone. That's all I would like to show for this video.